And so for R2, showing the relative stability, and R1 is infinitesimally interacting with R3. Vibration produces the scintillation through, or mass scintillates through vibration. But for R2, R1 is stabilized. R0 is completely stabilized. There is no set of nothing. R1 vibration with a physical characteristic of frequency that is relatively stabilizes, and it infinitesimally interacts with our current dynamic. R2 is relatively stable, meaning we still have E equals mc squared, energy and mass directly relate. And again, the vibration interacts through the mass, through the energy of the light. But the point being is for R2 is we have the base E. And this is kind of the big one, because this is inflation. This proves inflation. Right? Whoever recently won, recently in the context of physics and research development, won the Nobel Prize for inflation. And then other people come out and say, look, inflation, there's a debate if inflation is actually real, which it absolutely is. Whatever you mean by the word, the physical, what you guys are intuiting is correct, right? Because there's no, from R2 transitioning into R3 is when form becomes, and when shape becomes, again, 10 to the minus 76th or 36th or whatever time of the beginning of the universe. And so, right, and then, well, first of all, what is the value of E? Well, what is E? Well, E is the base of a natural logarithm, right? And so you have the form of a logarithm, log base A of x equals b in the exponential form. Again, a logarithm is an exponent, so exponentiation, right? Now we're trying to find the rooting, so logarithming, but just exponentiation, take a logarithm, and trying to generalize that word for completeness. But in exponential form, a to which exponent equals x. And so it's just two forms of the same notation. Again, your fundamental dichotomy of two. But nobody really knew what the golden ratio was because they hadn't made that connection to vibration at all. But a lot of interesting things obviously happen with E, because it's all over. It's in finance, it's in compound interest, it's in radioactive decay, it's in exponential growth, which is this is why it proves inflation. Again, it's the reason E exists is because of the inflationary epoch or epoch or however you pronounce it. But the actual numerical value, again, they express it as the limit of n, or the limit as 1 plus 1 over n, parentheses to the nth power, basically just taking the term, the 1 over n to the nth is going to bleed off. It's going to become so minuscule so quickly that it just becomes really small. Again, the important things are these are whole numbers, right? Dimensionality 1. For our universal evolution, you would expect it to be 1 in change and not terminating, which exactly is what it is. And same with 2. The numeric value of E is like 2.7 something or something. I didn't even write it down. But the point is, it is more than 2, and it is above more than 2.5. So the universe had progressed, it reaches peak, and then it stabilized, and then it reaches that point of no entropy, bam, stabilizes another property because it has to learn about itself, and then bam, you have a new property. And so that's where we get mass that manifests through momentum. But you have the derivative of e to the x is e to the x. And so what to make of that logically, not really sure. But then this is kind of, you can derive all of calculus from this through the concept of derivation, right? Integration, derivation. You're building something up, you're tearing something down, you start with a function, you derive it once, then you get the slope of the tangent, or you get the velocity if it's with respect to time. Because I'll probably go into the terminology of calculus more. Right, a derivative is with respect to this. X, the derivative, the change in position with respect to time. How much distance did they change in this amount of time? So the concept of derivation and derivative is outside of just calculus, right? It's with respect to this or that. So you have a fundamental relationship of or. And now we're back to sensorality, right? And then we can have the dynamic limit of sensor, right? Go from so to or. Soar, S-O-O-R, soar. But then you get, right, the word sore, like that's what we were doing last episode. I pulled my muscle. It's sore. It's tense. We're not going to do the physics now because that's going to be a whole other episode after this one. But with respect to the concept of derivation is well outside of just calculus. And it's logically consistent well outside of calculus. Because that's what I'm saying, I'm deriving another axiom. I'm deducing logical facts from the empirical world around me. I'm deriving logic from the empirical world, which is how anybody learns anything, whether that's from another person or from just the inanimate objects themselves. But derivation is a big concept, but E, again, it's exponentiating. It's getting faster at a faster rate. And so that is the universal inflation. It gets really, really big, and then it peters out. Well, actually, again, R2 stabilizes, so now we're in R3. And so here is the huge, actually bigger result than P versus NP, is people will say the universe is expanding. Categorically false. Major result. The universe is not expanding. The local universe, our local section of the universe, is expanding. We're a small planet around a small sun in the new section of a galaxy in a new galaxy. And so the fundamental stability, when we have mass, you have a moving, you get charge, and charge and magnetism are already unified. Again, I don't like the word unified, but they're just shown that the same physical phenomenon, the rhythm and vibration, and energy. Again, like I said, I'm not invalidating the concept of the expanding universe. So meaning the universe as a whole. The word universe means everything. And so our section, because we're new and we're in the stabilization of R2 from light into mass, the thing you get is charge / magnetism. A moving charge induces a magnetic field. And so that repulsion, and then you have no magnets, there's no magnetic monopoles, fundamental stability to physically, and so you have repulsion. So the expansion is caused by the magnetic repulsion. That's it. So it's not caused by dark matter, or I guess that one's dark energy, which doesn't even make sense, and like for so many reasons. But because we are new, and so we know that it's asymptotic, those phase changes of the universe happen extremely, extremely quick. And so because the universe is expanding locally, we know that we are a new part of it. But because we know in the same way you learn something. If your skills transfer. Let's say you're a decent, reasonable, logical person. And you take economics. You've never studied economics before. And you go apply yourself. You're going to learn most of the basics to about 85% proficiency in the first 2 weeks. And then they go from 85% proficiency to 99% efficiency is going to take you the rest of your life. And right, you can use a RuneScape, old school RuneScape example if you play video games out there. Right, 99 or 92 is half of 99. Right, in the game, it's you play a game, you build skills, and the amount of experience points you need to get from level 92 to level 99 is literally half. So once you're at level 92, you're halfway to 99, because from the levels 92 or levels 93 and up you need way more experience. And so the universe, these phase changes happen very, 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 very quickly, the most of it. And so most of R3 is already stabilized. We're just in a section of it that's kind of new or younger. It's kind of the same wording we would use. And so R3, we're not even into R3 yet, but the R2, the dynamic limit of that inflationary period, stabilizes in the presence of E for compound interest, for radioactive decay. I mean, these are all, again, things of stability and of growth. And so the universe as a whole is expanding way, way, way slower, right? It's expanding at an accelerating rate locally. It's expanding universally, but in the same way you have a maximum, and then in calculus, and they say is it a universal or global maximum. Universally, there is expansion. It is profoundly slower than it is in our local section. Proven, that's humongous. But we're getting to, but the element E is the dynamic limit, is the universal constant of that phase change from R1 to R2. Then now R2 to R3, and R3 being unstabilized, it is how we're interacting. I exchange mass, and my weight changes. I can go exercising, I can go eat. We already said those things, but that's the dimensionality we are in 3. Everything I've ever said, everything you've ever said, everything anybody that has come before us has ever said, or anything that will ever come after us that will be ever said, is in R3. And so in the present. But again, the present's not really defined because time has to elapse. And so we have the past and the future, and we're this interplay in between. But the circumference, again, I don't like the overall limitation notation for E. For pi, again, you're relating the diameter to the circumference. The circumference is always going to be bigger than the diameter. So again, once again, you're going to have a number larger than 1, but it's 3.14. So now we have a number less than a half. Right? If a half you're going to round, like physically you're going to round in the same way you round a syllable. The universe rounds up, it approaches complete entropy. Once that entropy becomes 0, there's nothing, again, you can't articulate the physical intuition, but then it expands, it gets a new property, and then it has to learn a new thing. In the same way you unlock a new level in a video game, and then the whole world feels new again. Same thing for the universe. But 3.14 is less than 3.5, and so we're new. We're new into dimensionality 3 in relation to the other universally stabilized constants. Again, constant, nothing is constant. Just the past, because it's definitive. But you're relating the circumference of a circle, which is very clear, and then for, I don't like the Fibonacci sequence, but for the golden ratio, and the Fibonacci sequence is effectively the golden ratio with a limit, but the physical intuition of deriving the golden ratio is better than using numerics for that. But I like I don't have what's the good physical demonstration for E, where it's compounding interest. Again, you're multiplying, so what's compounding? If you take an exponent, 3 squared, you're taking 3 times 3, so you're just using multiplication. So kind of the base gets bigger, or the iterations of the multiplication gets bigger. Just nothing super insightful to say there. But again, the golden ratio, E, and now pi, those are our universal fundamental constants. But really, they're specific cases of the dynamic limit, right? Showing those phase changes of when you can't measure something. The moment my hand hits this hand, and it transfers that momentum. The moment that momentum is transferred to this object is what the dynamic limit represents. What it covers, it encapsulates the completeness of things you cannot measure. In the same way you can have, again, you can have a certain temperature in the underlying states you don't need to know of what molecule's doing what specifically, just the overall state of the substance. You can get the temperature. You don't need, actually I don't even really like that connection, but that's what's going on. And so the dynamic limit, again, it maps that for all constants in all of physics and mathematically all constants. Because for the empirical physical fact that nothing is constant. So you can't have a constant mathematically. It's not logically consistent. And so now, we talked through pretty much everything I wanted to on that. But now how does this approach the P versus NP problem? And again, proving the generalized form of all physical constants is so mythically past just the P versus NP problem. It's hilarious. But anyway, we'll address that problem, right? They just have a question: does P equal NP? And then they have definitions between a complete problem, a logically complete problem, or again, their definitions are all wrong because words are naturally defined. The way you create a contradiction, because contradictions don't exist, is to project, to say one word, to say something you don't know confidently. But what was I saying? But then we get to the concept of identity, right? The universal identity of those universal phase changes, the dynamic limit representing the momentary time a new property is stabilized. And so when your identity, last episode we talked about how all of any bit of measurement has come from an individual, whether that's a human, non-human. I mean, the concept is very clear that an organism, an individual, autonomous organism has to make a decision, has to censor, has to make a choice to gather some sort of information. But so all of our data comes from a subjective perspective, and we're trying to make all of those discrete subjective experiences coalesce into one objective reality, which is the world we already exist in. And so the inconsistencies come from ourselves personally. But the identity matrix, or the identity statement, I equals I, or 1 equals 1, or chair equals chair, Because of infinite uniqueness, I can only be me. You're never going to be another human being in your life, or a dog for that matter, or an elephant, or a giraffe, or an alien for that matter. You're always going to be you. I'm always going to be me. So very intuitively, we have this concept of infinite uniqueness, right? Speciality, differentiation, the tendency to differentiate for sexual antagonism. And now we're going to bridge that logically, and sensuality is going to be the desire. The operative word now that we're going to change is desire. Speciality differentiates. Sensuality desires. And sensuality contains speciality. Right? It's building upon, we have to contain the previous properties of the previous phase states. You're still you, even if you mature and grow, you're still that shithead that you were, you just have a new perspective. Comprehensivity versus completeness. Intricacy and nuance versus bland and it are not discrete or not distinct. And so nothing can be anything else. And so does P equal NP? No, it can't. It's logically impossible. Nothing can be exactly anything else, is really what they're trying to say in completeness. Or the dynamic limit maps that entropy, maps that disorder. With logical consistency, proving speciality, again, back validates all of these things. I'm just rederiving another axiom. And so P can't equal NP. Nothing can be whatever P or NP could represent. A complete problem, a computational problem, a hard problem, a non-complete, super hard alien problem, doesn't matter. Each thing is infinitely unique. Again, if you take off a factory line, pens being mass produced, like the things you write with, just mass produced, they're still different. You might not be able to tell it visibly, but the little engraver had 1 micromillimeter off over there, and that's different. You could see it under a microscope. Everything is fundamentally unique. And intuitively, no one would debate that, especially from a personal perspective of being, you have always been you, you will never be anyone beside you, I will never be you, you will never be me. And mathematically, it's the exact same. So no two things can be exactly equal besides the identity. And so, right, we're all connected as one. So we're all rooting, right? The concept of rooting, whether it's the Riemann hypothesis or any other function, what is the basis? What connects us? Well, that's sensuality. That's our universal experience. And so there is no complete equality except for 1 equals 1, I am me, I equals I. And so that is an axiomatic derivation or definition. And you can literally just say P equals NP is trivially, it's not possible. Whatever those words can mean, you don't have to tell me what those words are. Does this equal that, and that is not this? It's not. If it's not 1-to-1 the exact same thing, it can't be exactly equal. And so it's just the axiom makes it where that problem is completely trivial. And so, but again, the dynamic, proving the existence and functionality of the dynamic limit in the first go through with speciality was just monstrous. And so I wanted to cover that explicitly. Obviously, this is a pretty long episode. I'll probably maybe break it down into 2 parts. But thank you for watching. Got a bunch more stuff to cover, and I will see you on the next one.